Greetings. A little while back I did a teardown of one of these iPod chargers, in fact a fake iPod charger that I bought on eBay. After testing and tearing down and blowing that one up, I looked on eBay and I found someone else selling genuine Apple chargers. Seller based in Wisconsin, so I ordered one. Eventually the parcel turned up, and because it taken so long to be dispatched in the first place, I had a free one thrown in as well. So parcel arrived from Turkey, and this is what was in there. Looks okay. Designed by Apple this time, apparently. Slightly more worrying when you look at the one that came with it, which has no writing at all. Here they are all together so you can compare. Here's my test rig. Just out of shot to the left hand side is my Variac. Then we have my power analyzer just acting as a voltmeter, that's monitoring the output from the Variac. Then we've got my Fluke, which is monitoring the output from the power supply. This is my dummy load, looking a little bit shinier than it did before. Last time I did the test it was on a breadboard. This is now built into an old BT NTU. The device under test will plug in here, and I've got the scope to monitor the waveform as well. And in case there's any trouble, I've got this. First up in the adapter, which is fused, the Apple one. Remember, these are rated at 100 to 240 volts, so they should be fine over here. There we go, 5.1 volts at 24 milliamps. You can see on the scope it's a very steady waveform. Let's dial it up. $400 milliamps, 700. It's dropping down now just below 5 volts. We've gone just over an amp there. Scope trace is nice and clean. See, when I go up to about 1.3 amps now it's starting to draw back down. So let's take it at just shy of an amp now. Now the last one I tested, when I dropped the input voltage down to 100 volts, it couldn't handle 1 amp. It's rated at 5 volts and 1 amp and it couldn't handle it. So let's see what happens. This is rated at 100 to 240 volts. Let's take it down. All the way down to just shy, there we go, just under 100 volts, and you can see it's still managing that comfortably. It's handling that no problem at all. Let's dial it down further. It's starting to get a strange waveform on the scope now. I'll dial it back up to 100 volts and that's gone. I'll take it back down. You can see it now, it's starting to struggle, but of course I am running at 60 volts. Let's just disconnect that and test the unlabeled one. Switch it on. Dummy load. And see straight away there's a big difference there Let's dial this dummy load back down. Offload, there's nothing really to report on the scope. Start dialing it up and straight away it's getting very noisy. We're on 300 milliamps, it's still handling it at 5 volts there. We've got this fine oscillation, which is similar, I think, to what I was getting before. And last time I thought it might have been the dummy load that was causing it, but I've changed the design this time and it's still doing it. You notice it didn't do it with the Apple charger. Let's keep on dialing up the load. Half an amp, and it's starting to drop there very sharply. So let's dial it back down. It can let's take it to about 500 milliamps there. You can see it's pretty much spot on. Let's try dropping the input voltage down to 100 volts. There we go. And you can see this time it can't handle that. 500 milliamps is dropped to 3 volts. I've got to take it down to less than 400 milliamps before it gets anywhere near the 5 volt supply. So that's definitely another crap one. And this Apple one, well, I hope this is a genuine one now, because I'm going to crack this open and see what's inside it. It certainly does the job. It certainly works like I'd expect a proper Apple charger to work. It can put out 1 amp at 5 volts at the full input voltage range of 100 to 240 volts without any noise on the supply. Let's carefully open this unbranded one first. Preferably without gashing my hand. Probably the best way now would be to push out with the USB. There we go. That, I think, looks much the same as the one I took apart the other week. Interestingly, this one does actually have a spark gap, albeit the spark gap across the bridge rectifier. The input there comes in, no filtering, straight to the bridge rectifier, straight onto the cap. And there's one transistor there, transistor there. I think it's much the same as the other one. In fact, we can compare it with the somewhat charred remains of the other one. There they are, side by side. It's roughly the same design. Now then, let's take a look at this one. Claims to be made by Apple. Behaves like it's made by Apple. Certainly tough enough to have been made by Apple. This is certainly a tough cookie to get into. I might have to Dremel this. You can see the difference between me trying to open this one and open the other ones. The first thing you notice when you open it, right on the input, we've got a toroid. So there's filtering in here. It's a lot tougher to prise these boards out than it is with the cheap ones. They don't just want to fall out. No way. There we go. And this is how Apple do it. And something else you'll notice, if I just scrape off the edges on that, this is the Apple case. If you look at the thickness of these walls and compare with the other one, there's quite a bit of difference in that. You'll notice in particular around the edge, around the corners, it's much easier to see there. It's not just this one, which is the cheapy generic one that arrived. That one is exactly the same. Now, the circuit is a lot trickier to take apart. You can see there's got this ribbon up inside, but there's also these connections here, which also link the two boards together. So I'm going to snip those. So you can better fold the boards apart. So as you can see, there's a lot more to the Apple one. There's a bit of gob on there, which I assume is just for holding it in place inside the case. I'm not going to do a schematic of this because Apple will kill me. But you can see it's a lot more detailed. It's not just the 1 or 2 transistor job. It's got a chip here which is marked Flex 01 GB022, which I assume is some sort of custom power supply chip. You can see it's got shielding in it, it's got electromagnetic protection, filtering on it. It's a lot more involved in this one than there is in the cheap ones. If we compare these side by side, bottom of the power supply, high voltage side, top side, top of the USB port, bottom of the USB port. There's just so much more going on in this Apple one. See how well this is made. Here's the outer insulation. And we've got, presumably, for the number of turns, that'll be the secondary winding. Then again, it could be just some sort of feedback winding. Let's have a look. I know bugger all about switch mode power supplies, so this could be just some sort of sense wire. I don't know. Right, there's that out. Right, found the end. So just a double layer of that. Then we have, yes, that'll be the secondary. As you can see close up, there's actually damage to the tape where the windings are pressed so tightly into it. So there's very, very little insulation there. In fact, you can see, I just about see, it's almost transparent there. Right, just found the end. And that's all there is between the primary and the secondary windings. There's 2 layers of tape. Let's compare that with this Apple transformer. I've already taken the top layer of insulation off. There was a bit of yellow tape on top of here, even though there's plastic over the top of the USB port there anyway. So I'm going to snip that off. Let's see how it's made. Right, so there's the transformer. The output terminals are directly wired off the winding. They don't go to pins on the board. And there's 2 connections there which are broken off, and there's 2 connections here, one of which, interestingly, goes around on this tinned wire. 2 turns are on the outside, which is unusual. Well, unusual to me anyway. Right, here we have it. And it's a round bobbin this time, no corners. Tape starts here. That's what we got. There. It'll be interesting to see if the insulation is any better between the windings on this. Right, there's the end. So what's that? 1, again, only 2 turns of that. The wire itself seems to have much thicker insulation on it. It's not just tinned copper wire. Sorry, it's not just enamelled copper wire. It's a much thicker material on that. And of course we have another layer of tape. So even though there's about the same amount of tape, you can see the difference in that secondary winding. Let's bring back, this is the secondary from the cheap one. Compare it with the secondary from the Apple one. In fact, I thought that wire looked familiar. If you look at the input to the unit, where we've got this toroid here, it's the same stuff, just with different colour insulation. Plus, of course, it has the added benefit of not terminating on the high voltage board. The wires exit the transformer via just a pair of fly leads to going straight onto the low voltage board. So there you go. What appears to be a genuine Apple power supply. They do exist, and yes, you really can make a full-blown power supply that small. Thank you for watching.